Administration of groups, quotas, and pseudo privileges. The theme of this nugget is controlling access. I'm going to show you how to use groups to limit file access to a set of users, and then we can use quotas to regulate the amount of disk space that users or groups can eat up. And finally, I'll show you how to use the sudo command, which allows certain users a limited set of special privileges. Let's get to work. Well, let's start this nugget the same way we started the last one, and that's with a review of some of the stuff that we learned back in the Introductory Linux series, and this time we're going to be talking about groups. So the basic commands that we learned before were group add, group del for group delete, and group mod for group modify. Alright, so you can see I've already switched over to be the root user on this system, and so let's do a group add command, and we're going to add this particular new group. It's called Project X. Okay, let me add another group while I'm at it here, and this time I'm going to call this one Project Y. Okay, so now I've added two groups to the system. If we look up in the etc group file, way down here at the bottom, you'll see the two brand new groups that I added, Project X and Project Y. They have a group ID of 504 and 505 respectively. Okay, great. So now I've added those particular groups to my system, and now if I wanted to add a user to a group, remember I do a user mod. I say -G, I give the group name like Project X, and then I say Perry. So I'm actually modifying Perry's properties to add the group to Perry's accessible groups. Okay, so my accessible groups now will be both my user private group, the Perry group, and also this group Project X. Okay, so I do that, and then let me print out the etc group file again, and you can see here Project X has Perry in the group after the last colon. Okay, so that's one thing that you can do, one way that you can add a user to a particular group. Remember one of the weirdnesses of user mod with the -G option. If I go in here now and say Project Y, Perry. So now I'm changing Perry's supplemental groups to include Project Y. If I wanted to change Perry's primary group, I would use the lowercase g and change that. But by default, your primary group in Red Hat is your user private group, the group with the same name as your username. So the capital G option changes your supplemental group. And so if I do this and change Perry's supplemental group list to include Project Y, well, one of the things that happens is, if I print out the group file again, is you can see now Perry is not in Project X anymore. He's solely in Project Y. Okay. So if you're going to add someone and you want them to be in multiple groups, then you have to do it like this. Okay. Now the pain with this is that to get someone into multiple groups or to add someone to a group, you first have to look up and see what all the other groups they're in. Otherwise, when you go to just add them to a new group with the -G command, if you leave out any group that they're already a member of, you leave that out of the list, they won't be a member of it anymore. This is an exclusive list. You have to list everything that you want them to be a member of, including the old stuff and the new stuff. Okay, so that's kind of a pain, I think. And so this is one of the nice things about the graphical user interface for groups. So let's go into the same graphical user interface we used last time called Red Hat Config Users, and we'll look at how to use this to modify groups, to add groups to the system and delete groups off the system, and also to change ownership or to change membership of groups. Okay, so here we are in the Red Hat User Manager, and you can see there's this Groups tab that will list out all the groups on the system and also the group members. Okay, back here under the Users tab, you can see all that's listed is a primary group. So now if I want to go in here and change a particular membership of a particular group, I can just go to Project X here and I can look at Properties. So I highlight that, and then under Group Users, I can select who I want to be a member of my group. And right now it's just Perry. Okay, and this is just a alphabetical list. So let's add the user Annie to this group as well. Okay, and we do this, and now Annie is also added to the group. The other thing that's nice about this that I can do is under Users, I can go to Perry and then say Properties, and go to the Groups tab and pick the groups that Perry can be a member of. So you can see already in here, I'm a member of Project XY and my own private group, Perry. Okay, if I wanted to change this, I can just click on a new box and add Perry to another group, and none of these other boxes would sort of uncheck. So I don't have to go through and look and make sure I know all the groups that Perry is a member of in order to update him and add him to a new group. And that's one of the nice things about the organization of this graphical user interface to manage groups. And just a little bit more of a refresher here, one of the reasons that we have groups is so that we can enable special access to maybe certain directories so that everyone in the group can access that directory, and in some sense they're sharing permissions over that directory. They're sharing ownership of that directory. So let's go to like the home directory, for instance, and do a long listing of all the files there of all the directories, and you can see here that the user Annie and the group Annie owns the directory Annie. And this is the way it's set up by default in Red Hat Linux with those user private groups. So this way Charles has his own user private group, and then Charles can set it up, or we can set it up so that Charles has administrative power over this group using like a group password command, and then Charles can add people as he sees fit to his user private group to share directories in his, or share files in his directories. Okay. The other thing that we can do as a system administrator is to make a directory here called Project X. Okay, and then if we do a long listing now, you'll see Project X is owned by the root, user root, and the group root. Okay, now if the root user wants to add or change the group ownership of this directory, then you use the change group command. You give the name of the group, and then you give the file that you want to change group ownership of. In this case, it's a directory named Project X. And we do this, and now we do an ls-l, and you'll see the group Project X owns the directory Project X. So anybody that we put into the Project X group will have access to this directory called Project X. And remember, there's the group mod to modify group names, and there's the group delete command that will allow you to delete a group off the system. Remember, for the group delete command, that the system will not go around and find files and directories owned by that group on your system and delete those as well. It will only delete the group out of the Etsy group file, and so no one is a member of that group anymore by default because the group doesn't exist. Okay, so if you need to clean up files, you're going to have to do that manually. And remember, you can't delete a group that is the primary group of some existing user on the system. Okay, so now let's move on and start talking about disk quotas. So the first step towards enabling quotas on your system is to make a modification to the FS tab file, the file system table configuration file. So let's print out the file system table configuration file on my system because I've already made this change. Now, one thing to note here is that the quotas that you're going to enable, like user quotas or group quotas, these quotas are going to be implemented on a file system by file system basis. So I can't put a user quota on, like the /temp directory, okay, unless I have a partition explicitly set aside for /temp. Okay, and so on my file system here, the partitions I have are / and /boot, and everything else is just other stuff like the proc directory or the swap directory. These aren't actual partitions. Okay, so the only two partitions I have to choose from is / and /boot, and since users aren't writing to /boot, it doesn't make sense to really install quotas on there, so I'm just going to install quotas on the / directory. So what I'm going to be able to do is implement either by user level on a particular user by user basis or on a group by group basis how much disk space those users or groups eat up in this file system, the / file system, the root file system. So here what I've done is I've added a user quota to this list here. So I'm going to implement user quotas on the / file system. This used to just say defaults, and I added the comma in the user quota. You can do this in any text editor, make this change, and then once you're done, you need to unmount and remount the file system. Now for the / file system, that kind of presents a problem. It's just easier to just shut down the system and reboot it, because the / file system is positively going to have busy stuff in it. It's going to have directories and things that are opened by various processes on the system. If this was something like /home, then you could unman and reman it, because probably no processes are going to have ownership of that besides the regular users of the system. Okay, so you have a few choices here. Go down to single user mode, unmount and mount the file system, something like that. Or just easiest for the slash directory, like I said, is just to shut down and reboot the system. Okay, so that's the first step towards enabling quotas on your system. Okay, then once you've made the changes to the file system table configuration file, now what we need to do is use the quota check command. And what we're going to do with the quota check command is it's going to go through the file system to determine how much disk space all the various users on the file system are using. And then it's also going to create this file in the top level directory of the partition or of the file system that we are enabling quotas on. And that file that's going to live up there is going to keep this information sort of up to date, how much data each user is using, that sort of thing, how much disk space each user is using. Okay, so let's put some options on quota check here. We're going to use A to check all the file systems, V for verbose output. C is going to create that file I was just telling you about. You can also run quota check after that file's already been created, and quota check will just update the values in that file. And you should run quota check time to time. You can put it into a cron job, for instance, and run it once a week or something like that. You definitely have to run quota check to update that file if the file system was not unmounted cleanly. If the file system was not unmounted cleanly, you need to run quota check to update that file that's in the top level directory. And that file that's in the top level directory is going to be called aquota.user. All one word, aquota.user. And for group quotas, it would be aquota.group. Okay, I'm also going to use the -m option here, and that's going to force quota check to work even though the file system is still mounted. And the reason is, normally what you would do is you would unmount the file system and run quota check on it. But for us, we're running this on the root file system on slash, and it's impossible to not have any processes owning something in that directory, in that directory tree, because it's the main directory tree of the whole system. Normally, if you were enabling quotas, you would probably have set up a /home partition for your system. I didn't do that. I just had two basic partitions, the slash partition and the /boot partition. And since /boot doesn't really have users writing to files in that directory, there's no need to run quotas on that one. So we're just going to establish quotas for demonstration purposes on the root level directory. And so that's why I've got to use this -m option. Okay, so I'm going to do this, and now it's saying scanning this device, SDA2, which is the partition that slash is mounted on. And then this is going to spin for a while and look through that whole directory tree to determine how much disk space each user is using and so on. And then I'll come back when this is finished, and then we'll see the next steps that we need to do to enable quotas on our system. Alright, now you can see quota check is finished. It's checked 7,900 and some directories and 124,000 some odd files. It says old file not found. That just means that the file that it was creating, aquota.user, was not there already. It didn't delete anything. It just created a brand new file. Okay, so if we list the top level directory here, you'll see the file aquota.user, and that's the information on the user's data usage on this particular partition. Okay, so now that we have quota check or the quotas all sort of set up, now it's time to actually impose limits on how much space each user can use. Okay, so to do that, we're going to use the edQuota command. Okay, so we're going to say edQuota Perry, for instance. That's going to help us edit the quota limits for the user Perry. Alright, so it takes us into the VI editor, and you can see the file system is SDA2, and this is the number of blocks and inodes currently in use, and then we're going to be able to set soft and hard limits on the blocks or the inodes. Okay, so first, just a word of caution here, not caution, but just advice, is that we'll probably stick to doing the blocks. Okay, this is just a lot easier and more intuitive in terms of limiting a user's space. The blocks, a block on the disk is usually about 1 kilobyte. Okay, and so this kilobyte chunk it can easily be converted to like megabytes or gigabytes or whatever you're going to limit, and that's a good way or an intuitive way that we think of space usage. Inodes has to do with how many nodes in the directory, like the underlying data structure that holds directory and file information is composed of these things called inodes. And these inodes, depending on how many inodes are there, all sorts of things can enter in here. And so this is not necessarily a very intuitive or easy limit to impose and really understand exactly what it's doing. So I'm just going to stick the blocks here. Okay, that being said, what I'm going to do is I'm going to come down here and I'm going to set some soft and hard limits for the number of blocks that the user Perry can have on this particular file system. Let me explain what these soft and hard limits are. Well, the soft limit is a limit that can be exceeded for a certain number of days or a certain grace period. So when we get done here writing in the soft and hard limits, then we're going to set up a grace period of like 7 days. So what this says is that the user can exceed the soft limit for 7 days, but they can't ever exceed the hard limit. And if after 7 days they're still exceeding the soft limit, then we're not going to let them create any more files and take up any more disk space. They're going to have to pare down and get rid of some of their files. Okay, so the soft limit is kind of like a warning limit. You've approached your limit, but we're going to give you 7 days to get your act together. But even in that 7 days, we're not going to let you go over the hard limit. Okay, so let's just do it like this. We're going to let's go into insert mode, and we're going to go to like 5 million, if I did that right. Okay, yeah, 5 million. All right, so the soft limit is 5 million. Okay, and let's make the hard limit like 6 million. Okay, so now that's 6 million. Yes. Okay, so we have a soft limit of 5 million, a hard limit of 6 million. Each one of these things is like a kilobyte big, each of these blocks. So this is a soft limit of 5 gigabytes. 5 million kilobytes is 5 gigabytes, and 6 million kilobytes is 6 gigabytes. And so there we have our limits, a soft limit and a hard limit on the number of blocks that the user Perry can use on this particular file system. So I'm going to save this file, hit escape, shift : WQ to write my changes and quit, and now Perry has the limits set up on the account Perry, okay, of a soft limit of 5 gigabytes. Now the other thing is, I said we were going to set a grace period, and there what we're going to do is ed quota minus t. Now this sets the block and the inode grace period, and you can see it's already set up to be 7 days. There should be no spaces in there. If it's 7 space days, it's not going to work. So just 7 days is the grace period for the users, for the soft limits to be exceeded. Okay, so that's how we set up. Let me just quit out of here. And that's how we set up quotas for a particular user. That's how we check and create the aquota.user file and so on. All right, well, now that we have quotas in place for the user Perry, we can do the exact same process to put quotas in place for any particular user on the system. All right, and now what I want to do is show you a couple scripts that are out there to go along with setting the quotas. These scripts will actually examine the quota limits and the user's usage of disk space, and then either send out warning messages or make reports as to what the current state of the system is. So first, let's talk about the warning messages, and let's look at a program in the etc directory called warnquota.conf. All right, so the warnquota.configuration file here has to go with the warnquota script. And if you run the warnquota script, it examines the configuration file that we're going to look at now, and it looks at, and it basically makes an email message to a user that's exceeded their quota. All right, and if they've exceeded their quota, then they're going to get an email message using the sendmail command from the root user with this subject line. It's going to be CC to this user, which is again the root user. The support email address is listed here. The phone numbers that they could call are listed here, and so on. Okay, so this is creating, basically, this is the configuration file for creating the email message when a user has exceeded their disk space, disk limits. All right, so and down here you can see is the actual message, and then down here is the signature, and that's the end of the file. So you can alter this file so that the email message looks exactly like you want it to. Okay, you can alter the message, the various phone numbers to get help from, or the email address, or the subject line, or whatever. Okay, you can make those changes. And then you should run warn quota, the script itself. You should run that every night. And run it, set it up as a cron job so it runs every night. And that way, for the grace period of 7 days that the user has to get their disk usage under the soft limit, then, they get an email on the first day that they've exceeded their limit. Otherwise, they'll exceed their soft limit and they won't know they're over their soft limit. And then will come the day that, they can't write anymore because their grace period's over. They can't write any more files in their directory and they're stuck. Okay, so the warn quota script just tells them, okay, well, fine, you've exceeded your limit, but you've got 7 days until, you have to get the files under this particular size that we agreed upon, blah, blah, blah. Okay, so that's the configuration file for the warn quota script. Now, the other script that I want to talk about is the report quota script. And this just generates a report on the usage, the disk usage of the various users on the system and how that compares to their quotas. Okay? If we use the -S option here, that just prints the data out to the screen in a nice, easy-to-read fashion, tries to print it out in like thousands of megabytes instead of, blocks and so on. Okay? So then we write report quota -S, and then we give the file system that we want to do a quota report on, and that's the /file system. And so I'm going to do this. Let me just pipe it through less so that we make sure we don't miss anything. And here it is, one page at a time. So you can see up top, the grace period is listed, and then down here, the left side, there's all the users on the system, and there's another page of users below this that we won't look at just yet. For all the users on the system, how much space they've already used, and then their limits, their hard and soft limits on blocks. Okay. So we can see here, there's a whole bunch of zeros in the soft and hard limits. That just means these users do not have any quotas set for them. All right. Whereas this user Perry here that we've already set up is using 37,736 bytes, but he has a limit of 4,883 megabytes and a hard limit of 5,860 megabytes. Okay, so when he exceeds the 4883, if we're running the warn quota script every night, then he'll get an email message saying, okay, you've exceeded this soft limit, now make sure you start deleting some files by the end of this grace period, which is 7 days. Okay, so that's the report quota script. Some people run the report quota script every night and write it to some directory or some log file so that they can keep track and go back and look and make sure that somebody's quota usage didn't spike up one night or something. If you want to go back and identify things, that's fine too. Certainly running warn quota every night is practically essential in order to give the user enough time in that grace period to make changes and start deleting files before the day comes where they can't write any more files. All right, well, the last thing I want to talk about in this nugget is the sudo command, and sudo just stands for super user do. And what this command allows you to do, it allows you to set it up your system so that you can give certain privileged access to certain users on the system. Now, the reason we want to do this is because sometimes users need to execute some privileged command that's within the scope of their job, but we don't want to give them full-on super user privileges over the whole system. So what we can do is give them very sort of limited super user privileges to allow them to accomplish their job. Okay, so the heart of the sudo program is the etc sudoers configuration file. And what we're going to do is look at the man page for the sudoers configuration file. So this is quite a long manual page, and it's got there's lots and lots of stuff that can be in this sudoers file. I'm not going to look through the man page. I want to go down to the bottom here and look at the example that they created. And then you'll see the simple example that I did on my system, and then I'll show you how to use it. Okay, so here we are. So here's the example sudoers configuration file, and they say some of these are a bit contrived. Okay, that's fine. I'm just trying to get across the point here of how you basically set up a sudoers config file. So the first part is these aliases. So the first alias here is user alias. So we create these groups of users. Like here they've done full-timers, part-timers, and webmasters. Okay, at the internet company where I used to work, the programmers had certain special privileges, then the system administrators and the operators had other special privileges, and so on. Okay, so here they have full-timers like Miller, Mike, and Dowdy. Okay, these full-timers will have certain privileges when we get down later on in the configuration file. But the reason that we create an alias here, the reason this is nice, is because then if some full-timer is fired or quits or something, we can just take them out of this list, and then they're off the system. The other thing we can do, if we hire a new full-timer, we can just add that person's name to this alias list, and then they will have all the privileges that these other 3 users were already set up for. Okay, so you can see the ones they've created here, like full-timers, part-timers, and webmasters. That's just arbitrary grouping of people. You can group them however you want. Then there's the run as alias. By default, if you execute a sudo command, you're really running as the root user. Okay, and here they're saying they're explaining what you're running as. And for these examples, it's root and operator and Oracle and Sybase. Okay, so now is the host alias. So these are the machines that you can run it on. So you can either break it up by like the architecture of the machine, like Spark, SGI, Alpha, so on, or you can break it up by like the network that it's on, whether it's on the CU network or the CS network. You can break it up whether it's a server or whether this machine has a CD-ROM drive, that sort of thing. Okay, and then as we go down farther, there's command aliases. So the command aliases are saying, what is the sort of group of commands that we want to let people execute? Well, we're going to let like dumps happen by probably operators. Okay, so they can run the dump command or the restore command. The kill operation, we're going to let some users kill processes. Printing operations, mess with the printer queues and delete jobs and so on. Shutdown, we're going to allow some users to shut down the system or halt the system is the next one, and reboot is the next one. And then we have shell access, and then we have SU access. Okay, all right. So now we have our user aliases and our command aliases, and now what we do is we go down here and we can see how we set this up. So here we give full-timers all access with no password to all of the commands. Okay, part-timers get all access to all the sets of commands. Okay, Jack here gets full access, all the access, but only on the CS networks. Okay, and then Lisa gets all access, but only on the CU networks. And then see, the operator gets full access, but only with regards to those commands that had to do with dumps, kills, printing, shutdown, halt, and reboot. Okay, so you kind of get the idea of how this is working. Then, once you've set this up, now the operator can go ahead and shut down the system, but the operator doesn't actually have the super user password, and the operator is not, the super user, right? So if the operator is logged in as himself, as the operator, and he wants to, kill a process, he can't just say kill and the process number. What he'll say is sudo kill and then the process number. Okay, and that will allow him to kill processes on the system. All right, so there's a rundown of the sudoers configuration file. Now let's move back out to this screen and look at the one that I created, the very simple one I created for the user Perry on the system. All right, so let's look at the etc sudoers file that I've created, and it's a very simple file, and all I've done here is create a user alias, and I've called it special user, and I've put Perry into that group. And then I've set up a command alias, file commands, so I can do things like the ls command, the cat command, and the less command. Okay, a very restricted set of operations, but it'll get across the point of what you have to do to execute commands with the sudo command. Okay, so then down here I've said special user. Anyone in the special user group can do the file commands on all the files. Okay, so what I'm going to do is quit out of this page here, clear the screen, and now I'm going to show you how to execute these commands. So first, let me exit out so I'm not the root user anymore. I'm back to being the user Perry. Okay, and now what I'm going to do is I'm going to say less/etc sudoers. Okay, and notice it says permission denied. All right, well, it says permission denied because I don't have privilege to look at that file as Perry. All right, but I am in the sudo list. So if I say sudo less/etc sudoers, okay, and I do that, it's going to prompt me for my password. And now I'm typing in my normal password, Perry's normal password. I don't know the super user password, right? All I know is my password. But the super user, the root user, put me in the sudoers file to have access to the less command. Okay, so I type my password in, and now I can print out the sudoers file here. Let me just hit Q to quit out of that, and that's exactly how the sudo command works. Notice that if I do the exact same command again, I don't have to type my password in. Okay, let me quit out of here again. And the reason is because once you type in your password for sudo, you have sort of a limit, a time limit, on how long you can do other sudo commands without typing in your password. Okay, but you still have to put sudo in front of each one so that the system goes to etc sudoers and checks to make sure that you can do the command that you're trying to execute right now. All right, so that's the sudoers. That's how you use the sudo command. A couple more notes here is the command that you use to edit the etc sudoers file. You have to be the root user to do this. Is vi sudo, all one word, vi sudo. But it's just like the vi editor. And the reason it's a special command is because the sudo configuration file, the sudoers configuration file, has very special formatting, and you have to follow that formatting exactly, or otherwise it's not going to be parsed correctly, and you'll get some errors. When you exit out of vi sudo, if you see warnings or errors on the formatting, you have to go back and fix them, or the whole sudoers file is broken and won't be used. Okay, so check out the man page if you need to understand exactly what you're doing incorrectly. And then one last thing is the file var log secure keeps track of all access to the system, all privileged access. It also keeps track of when the root user logs in and out, that sort of thing. But it will keep track of all successful and unsuccessful attempts to use the sudo command. All right, well that wraps up our discussion of sudo. All right, well, it's time to wrap up another nugget. In this nugget, we started by talking about administration of groups in Linux. I refreshed some of the commands from the introductory videos like group add, group delete, and group modify. And remember, to add a user to a group from the command line, you use the usermod command with the capital G option. And then I showed you how to use the Red Hat config users graphical interface to do group administration. And for some things, this is nicer because you can pick a group and then select the users you want to add to that group, or you can pick a user and select the groups that user has to be in, or you want that user to be in. And then we talked about quotas. First, we had to modify the etc fstab file to say that we're enabling quotas on a particular file system. Then we used the quota check to set up the aquota.user file or the aquota.group file, whichever we were implementing. And then we used the edquota command to actually set quotas for particular users. And finally, we wrapped up by talking about the sudo access. Okay, we talked about the sudoers configuration file. Remember, you have to edit that with the vi sudo command. And then we talked about how to use the sudo command. You say sudo, and you follow that by the command. And then you'll be prompted to type in your regular user's password so that you can gain access to that special command that you're trying to execute. All right, well, I hope you found this nugget informative, and thanks for viewing.